Hey everyone, thanks for attending our talk. I'm Lior Lieberman. I'm engineer lead at Google.
And I'm Igor Velichkovich. I'm an engineer at a stealth startup focused on AI infrastructure.
Yeah, and today we're going to talk about encryption, identities, everything in between, kind of some tips on building secure Kubernetes networks, and some of the hopes we're hoping to get out of this presentation and out of standardization efforts in this aspect. But I'm going to hand it off to Igor to kind of walk us through and get us into the domain.
Yeah, so let's start with a story. So suppose you have this environment, you have some ingress coming into your cluster and a proxy pod, and you have a rate limit config. Pretty common setup, right? But now you have some issue with your rate limiter. It's not rate limiting what it should, and it's over rate limiting other things. So you need to go and troubleshoot that. So you add a debug path and a debug pod because you remember that the rate limiter is based on headers. So you add the debug pod to intercept some traffic and try to see what's going on. That debug pod is meant to be temporarily lived, and you do figure out what's wrong and fix your rate limit. But because it was supposed to be temporarily lived, it has broad, unrestricted network access, right? You didn't bother to secure it. So you can see in the graph that debug pod can access everything in your cluster. So that ingress was exposed on the public internet, and you forgot to clean it up. So now suppose someone gets into that debug pod, and they start accessing your user information, payment information, transactions, and the attackers move all over your network because you don't have any segmentation. After this, you have reputation and compliance issues that follow. That was a made-up story, but this has happened many times in the past. So this is a good example. This led to chip and EMV cards in the US. They weren't really very popular before that, so it had like a cultural impact. But attackers got into Target, and they were able to steal 70 million people's PII, 40 million credit card numbers, and they got in through a weak link in a contractor, through an HVAC contractor, that was using free anti-malware software that was not robust enough. The weak link thing is going to be a pattern that you'll see in the following examples, where someone is able to get in through a weak link in your security, and because of the lack of network segmentation, they're able to get to other more protected resources. So another example a lot of people probably remember is Equifax. 148 million people's personal information was stolen, including social security numbers and financial records. There is a vulnerability in Apache Struts that is used for Java web applications. And again, once attackers got in through that one weak link, due to no network segmentation, they were able to move to more highly protected assets. This is an interesting one. So Starwood Hotels and Resorts, Marriott, there were several breaches that were long-term breaches, but essentially hackers got in, and then they moved across the network, installing keyloggers, Trojans, all kinds of stuff, getting 339 million personal data records. So what's interesting about this one, though, is that Marriott was purchasing Starwood, and Marriott knew, Starwood disclosed that they had a breach, and Marriott knew about this, so they tried to do their due diligence, and they did a 10-month security assessment. Well, they missed an ongoing breach, and due to poor network segmentation, once they purchased it and integrated it into their network, that breach spread to Marriott. So again, it's either a weak link in your software, or even something that you purchase and integrate, and then that ends up, spreading across your network and getting into all kinds of stuff you don't want it to. So what should have happened? Well, that's our topic today. And how can you protect yourself from situations like this? The main thing to do is going to be to secure your network. So what does Kubernetes offer today? There's Network Policy v1. That's been a stable API for a long time. There's new admin network policy and baseline admin network policy. And there's also RBAC for securing network and access to your API and controlling in your cluster. So we'll go through network policy first. So this allows app owners to control ingress and egress from their apps. It boils down to IPs, but it uses, like when it's implemented, it boils down to IPs, but you can put direct CIDRs in there, or you can put, it's really common to just use namespace or label selectors. The key thing to note here is it's a namespace scope policy. It's installed by default with Kubernetes. The CNI needs to implement it for it to work, but it's been a stable API for over 7 years. But the key thing here is it's namespace scoped, right? So it's designed for developers, namespace admins, app owners to control their traffic, like maybe between a front-end pod and a back-end pod, or the back-end pod and the database within that, application and those microservices. So network policies have some gaps. There's an implicit deny. So policies only specify what's allowed, and that's been a bit of a source of confusion. There's no support for cluster admins. So these are namespace scoped policies, right? And there's no way for admins to kind of globally secure the cluster. Policies, this is a big one. Policies are at the IP level, not at identity. So it's kind of implicitly using IPs as like identity for the security of what the pod can and can't talk to. And it's using labels often to derive those. So now labels are a security boundary, and that can be a little funky, and they're not necessarily a real identity. Lior will talk a lot more about that later. There's scalability issues with large clusters. Like imagine you have 20,000 pods, and you have all kinds of different subsets of labels and groupings, and those pods are churning, and you're constantly updating the IP rules on like all of your nodes. Eventual consistency, right? So like when a new pod comes up, everything needs to get synced. And there's limited support for north-south traffic or external to the cluster. There's work being done in this area, but right now you can kind of specify a CIDR, but it's not really well supported. So to try to address these gaps, there's admin network policy. So the main thing to notice here is that it's a cluster scope policy, right? So these are non-overridable, and they allow an admin to control the rules globally for the cluster. So in this example, you can see that it uses similar semantics, right? The label selectors. And in this example, it's allowing your monitoring namespace to talk to all namespaces because you need to monitor things, right? This also adds support for deny and support for priority. So you can go at a higher priority and say monitoring can talk to everything except for namespaces labeled security restricted at a higher priority. We're going to deny that. And finally, you can also pass. So you can allow, deny, or pass. And in this example, even higher priority, if the namespace is labeled security internal, we're going to pass it. And what that means is it'll be up to the namespace admin to use network policies to control their traffic. This is an out-of-tree installation, so you got to actually install a CRD, and it's a V1 alpha API. There's a lot of work going on to get it to beta. If you were just in the SIG network talk, they were discussing what they want to do to get it to beta. And it requires a network plugin implementation. Baseline admin network policy, this is another one. This is for that default deny. It allows you to, it's a global resource named default, but it allows you to define what happens if you don't have like a network policy that applies to your traffic. They're actually looking at combining these as they go to beta, but it exists now. So that helps with the implicit deny, and it helps with supporting cluster admins. But we haven't really handled identity, scalability, north-south traffic, and we've added a new gap. There's increased complexity because now you have layers of admin network policy, and you have all these different resources, so trying to figure out what's going on and what's applying to your traffic can be complicated. There's a lot of tools that you can use that SIG Network's been working on that can kind of help you map this and test this and see what's going on. but it does add complexity.
Nice. Yeah, and just, before even moving to the gaps, shout out to some of the folks here. Like as we've seen the Sig Network updates, there's tools like Policy Assistant, for anyone that use admin network policies, tools like Policy Assistant that, can do a variety of things that can help with that, but it's still more complex. So how do we go about addressing these gaps, right? So first I want to quote John Howard. John is a Istio maintainer and has been doing a lot of work in this area. And John compares this problem to a security officer, security checkpoint that check for employees. And John's saying that the strengths of the checkpoint vary substantially based on how we identify employees, right? Whether it's a company t-shirt, that means it's our employee, whether it's a fingerprint scan, whether it's showing a badge, all of these options would substantially, would yield to substantially different results, right? And the same thing applies to network policies. And I do encourage you reading this blog because it talks about a lot of different useful things. But this is the first thing we want, right? We want to ensure that identity is something we rely on. Now, another thing is immutability of this identity, right? If the identity is fixed for the pod's lifetime, there's no risk for label changes because I'm not sure like how many of the people here know, but labels can change in runtime. Nodes have access privilege, like especially kubelet, to changing labels, and there has been some CVEs and attacks around that. But also, if the pod's changing on runtime, it means that if we tie the policy to the pod labels, then how can we be sure that the policy is not changing on runtime? Now, with immutable identity, there is reduced attacking surface, right? If a pod is compromised, right? So if a pod is compromised and the IP address is reassigned to a different pod, right? Sorry, I forgot about that. So there has been cases where pod came up, right? And then it got an IP address. And then because we're using label selectors, the IP address is what we are denying or allowing to traffic, right? So, but when a new pod comes up, if we're caching these network policies, it means that right now a new pod, it should not have these, right? It can have different labels, but it has its IPs, can basically get access that it shouldn't have. So that's the whole story, but forgot to mention this here. Additionally, immutability ensures that the policies remains predictable for the lifetime of the pod. We talked about it, identities like service account, as an example we're going to see in a minute, remains fixed. Nobody can change the service account of a pod on runtime, so it requires a restart, and then gives us the policies to be predictable. Now, can we tie it to Kubernetes primitives? Obviously, we just enumerated some things we want out of the policy. And yes, service account is meant to be an identity. We're attaching RBAC, we're attaching policies to it, right? It clearly satisfies the request we were saying. And it's also hard to manipulate, right? Because service accounts are also tied to RBAC. We're giving RBAC, for example, a pod usually cannot change its own service account. So even if a pod is compromised and if it needs to escalate privileges, meaning changing a service account to a more privileged service account, it will require a restart, and by the time it restarts, it may be that the pod is not compromised anymore. Now, before we go and talk about more implementation of that, right? Igor mentioned some of the problems being scalability. It's just to illustrate that. So when we talk about label selectors, right, which again is not an identity, these label selectors produce subset of pods. Now, when we talk about ingress and egress rules, so it defines these access controls between these subsets. Now, when things get complicated is when we're querying for these subsets. It's pretty expensive for the data plane and control plane to do because we may have overlapping subsets. We need to enforce an order of evaluation of the policies. And querying for all the subsets, although Kubernetes API gives us a lot of the good machinery to do it, it's very, very expensive, and it's very hard to implement as well. Now, the questions we're asking ourselves, can we instead transmit the entity as part of the networking packet, right? Right now, it's not there. We have IPs, but if we are able to transmit the entity as part of the networking packet, then we can save the mapping between labels and IPs and some of the eventual consistency nature of it, and being more strict and secure about the network? Can we enforce on something else other than IPs? Now, there are many, many specific solutions. Not necessarily all of them satisfies what we said, but partially some of them are. But you can see I'm highlighting specific solutions. I'm going to go over 2 of them right now. Some leading projects. It doesn't mean that this is the complete list. There are many, many other projects that implement the APIs. But I want to start with Cilium network policy. I guess a lot of people here know Cilium, very widely used CNI. And Cilium network policies enriches network policies, like core network policies, and providing L3 policies on the IP level. And it provides, various, as we see, useful abstractions. I just listed 2 of them, but which you can, you have a list of predefined entities that you can use, or you can do from security groups with AWS. But it provides, again, values abstraction, but based on IPs. At L4, it provides similar support for port, protocol, and it also provides extended support for L7, all in the same CRD, by the way, which obviously we know that the L7 functionality is enforced with the node local envoy proxy. The CNI level cannot enforce the L7 capabilities there. Now, Cilium also supports egress and egress policies. There is support for deny policies, as we see with, as well, admin network policies. And similarly, there is the cluster-wide that is basically, giving the solution for the cluster admin, because we said network policies is for the application developer. Now, similarly, we have Istio authorization policies, which some of you heard of. It's a different name, right? This one is network policy, this one is authorization policy, but it is mainly to provide the same functionality, right? Network segmentation. Now, Istio supports the enforcement not in the L3, not in the IP layer. It supports enforcement on the L4 TLS and the L7 layers. And what it means, for all of you that are keeping up to date with the advancements, right? Right now we have 2 modes in Istio. We have sidecar, we have ambient. We're not going to go into this. But the enforcement basically happens in different parts in these modes. But within Istio, the pod identity is one-to-one with the service account. And it's distributed as a certificate from the control plane to the proxies. And within the certificate, there is the SAN field, subject alternative name, where we could encode the identity, being the service account. And the identity is usually using the SPIFFE format, which is an increasingly common standard for actually describing this identity. Now, we can see a little example on the right. I'm trying to keep examples throughout as I go, but not kind of spend a lot of time on that. But for example, in this example, right, we're allowing payments backend. We're allowing traffic to the payments backend from the payments front identity, as an example. Now, Istio supports as well external authorization, which is something I wanted to call out. So you could delegate, authorization decisions to a different application, a different webhook. We know things like OPA or any other callouts we can do. There is support for deny policies and default deny controls. And there is support for cluster-wide policies with some semantics, for those using Istio with putting the policy in the Istio namespace. But there's no support for egress. So again, this is just a rundown of what's supported or not. But as you see, like these 2 leading projects, right, which a lot of people probably use, provide the same goal, right, same purpose, network segmentation. How can we secure traffic within our network? But there's no standardization there. It's widely different. And why there's no standardization? Because standardization is hard. Now, what is, why is it hard, or like, where are the areas which we identified needs more standardization, right? What's a standard identity? Is it pod labels, right? Is it service accounts? Is it SPIFFE IDs? What is a standard format, right? Is it JOTs? Is it JW? Is it X509 certificates? Is it SVIDs? SVIDs, for those who are not familiar, is a new identifiable format that the SPIFFE project defined. How do we distribute and issue the identities? There is a cap in Kubernetes, also known as the pod certificates cap, that suggests that kubelet is going to be the one issuing identities and basically distribute them to all the pods. Is it sufficient as a new standard? is all the ecosystem is going to be developed and use these identities? We don't know. What's a common root of trust, and what's the interoperability semantics between L4, L3 that we talked as well, and L7 enforcement? How do we compose all of them? This is something we're kind of living day to day, trying to understand and deal with. But it's increasingly important to do some standardization in these areas, because if there's no standardization, then different implementations implemented differently, which can yield to some security breaches or some difference. Now, what you can do now, I'm not gonna put this slide and tell you, hey, just employ zero trust, defense in depth. Obviously, there's like common patterns that you probably want to use. But in the practical part of our presentations, if you are using labels as a policy entities, make sure you're using admission control on those labels, right? Because you don't want anyone to be able to change the label, because we often think like, changing a label is not something that's that's giving a lot of permissions. But you probably want to use things like Kivernal, things like Gatekeeper, things like that gonna basically provide admission control for changing the labels. And for the labels you're using to tie policies, you want something stronger to validate that no one can bypass your policies. Now, if you're using identities, it sounds magical, no, but make sure the identity is transmitted. So in the ISTU case, the identity is transmitted with the encryption over MTLS, meaning if you disable MTLS, if you're disabling encryption in your cluster, you cannot enforce authorization policy. So just, it's obviously just a high-level overview, but make sure when you go about securing your networks, you actually understand what is the implications of doing something that are related in this field. Now, obviously, what should have happened, and just to complete the story, obviously, right, there should be zero trust and defense in depth, right? MTLS should have blocked potential impersonation of the debug pod, because if we have MTLS, right, so every service presents its own certificate, and it's much hard to impersonate to a different service. Authorization policies should have blocked the access, because the debug pod should not have been deployed with an identity or in, depends what you're tying on, but or pod label that actually have access to anything else, right? We just wanted to get a request, dump the headers, and inspect them. And similarly, obviously, the service account should not have any API access, because it didn't need to. So these security postures should be, especially if we're a platform engineering, we're the people that kind of take care of the platform, we should make it easy for developers to make this decision operate in a very security conscious way. Now, lastly, standardization is important, right? We said it's hard, but it's extremely important. I just listed two of the things here. One of the pod certificates cap that I talked about. I think it's cap 4317, which is progressing and, as I said, trying to standardize the issuance of the certificates. The other thing is a GitHub discussion happening on the SIG network policy API group about gathering use cases for using identities and not IPs from the UX perspective, actually, not from the security, because from the security, it's different. But from the UX, would it be easier for users to reason about their workloads with identities and not IPs? Because usually the developer, they just spin up a pod, a workload. They don't know what IP is going to be assigned. And these two Slack groups are the best place to actually go and talk about it and ask questions or, bring up your idea. And there's pretty responsive folks there that can help you, driving this area. Yeah, with that, I think we have plenty of room for questions. More precisely, 5 minutes. And yeah, thank you.
Do you know where the mic is for questions?
Yeah, the mic should be behind, right? Oh, there's a mic just here in the middle.
Oh, we got someone.
There's someone? Or, yeah.
Hello, thanks a lot for that presentation. I have a question about authorization between two services. I have a use case where the authorization is changing regularly between two services. How would you manage that?
Well, Can you elaborate more on the use case? Like, so
Yeah, so I have a key lock, and I have two microservices, and the authorization between these two services is managed by key lock. But since it's administrated by other people, sometimes the authorization is changed. Like the scopes, O2 scopes are changed regularly.
And what's the ideal scenario you would like to get to? Like, does it change because it's supposed to change? Do you want to enforce something else? Like,
no, I just want to know a little bit about how the policies are updated. Is it at every request made between each of the services, or is it something else?
Well, definitely. I mean, stay here, and we're going to follow up on that. But I think in theory, right, you want to segment your network. You want to understand, hey, I have this microservices, and theoretically, these microservices should talk to that microservices. You know, obviously, back and front end being the obvious case, but you know, everyone has their own. And once you segment your networks, you want the policies to be predictable. If you need the policies to be changed dynamically, maybe you want to use something like an external authorization mechanism, as we see with a custom authorization, where you say, hey, I don't want my policies to be predefined, but you know, delegate my policy enforcement decision to something like OPA, to something like other providers. What is it?
Yeah, sorry, I was saying like Google Zanzibar or something like that. Yeah.
Yeah, like anything that implements this protocol. There's a bunch of things out there, and then you could use this this mechanism to actually provide the authorization decision, and which obviously can be changed dynamically, whether it's integrated with your IAM provider or whatever. Yeah.
Okay, thank you very much.
No problem.
Hi, I was wondering if you had any tips or what you used for observability into troubleshooting networking issues in regards to network policies versus security groups versus WAFs or anything like that.
Yeah, definitely. So if you go and look at the network policy level, oftentimes you would have a feature. I mean, maybe in different implementation it's called different, but a thing called network policy logging. So it logs authorization decisions, and there's a bunch of useful observability tools that kind of go on around that and present it to you in whatever observability dashboard you're using. There was in the previous SIG network discussion, someone asked about whether we want to standardize the format of this logging, for example, because right now it's not standardized. So this is being discussed. There is actually issues about that, but I can tell from a vendor perspective, for example, within Google, we provide this network policy logging, which you can use. There is as well some tooling, like I think the policy assistant, as I mentioned before, that can let you actually simulate what would happen if a network, what would happen if a policy would be deployed. So would your traffic being denied or not? And I think same thing if you kind of go above, right? When you go like to L4, like L4 TLS or L7, again, like useful logging from whether it's the Envoy, it's something that you can definitely use. Yeah, I hope that answered your question.
Thank you very much.
Yeah.
Hey, that was super interesting. I'm interested in or intrigued by the sort of direction of going towards certificates in X509 for client auth. I guess I'm interested in what's driving that, whether it's convenience or some other technical reason. And I guess the reason I'm asking is because I'm sure you're aware, X509, ASM1, these are pretty old things, and the PKI comes with a bunch of operability issues around, revocation and like issuance and lifetimes and all that sort of thing. I guess my point is, we know we can do better than X509 when it comes to authenticating. That's why MTLS isn't everywhere, right? It's only in very small places, usually. So what's driving that move towards kubelets issuing certificates rather than those other standards you talked about, like JOTs? I'm not a fan of JOT either, but there's other ways of doing this that are simpler and have less of a history of vulnerabilities and parsing issues.
Yeah, that's definitely a good question. And by the way, good feedback. Feel free to go to these issues and put your feedback there. But like, for example, one of the things you mentioned with JOTs, right? JOTs, for example, operating only on L7. What happens when your traffic is not L7? How are you gonna enforce that, right? So MTLS and certificates being one of the ways. By the way, anything in the KEP, like in the Kubernetes enhancement proposal I linked, is not being opinionated about how do you transmit the identity. It's just, okay, how do I distribute, how do I issue an identity? But MTLS being one of the ways that, for example, Istio happen to use to, or any mesh, to transmit an identity, and then when you have MTLS over the network, it's easier for you to, to decode the certificate and use it for enforcement.
Yeah, that's part of what we talked about standardization being hard. There's a lot of different ways of doing this stuff, but the key point is that we can probably do better than labels, and we can do some form of identity.
Yeah, and definitely, go to like these barcodes, like, put your feedback there. If we want to standardize on, obviously we want to standardize on something that is most commonly used, right? Like, there are some things that are not commonly used and going to be harder for people with the Kubernetes ecosystem to adopt. But, obviously all the things you said, we can do better than that. Why wouldn't we do better than that? MTLS is not necessarily everywhere. So yeah, if we can standardize on this identity mechanism, then maybe we can standardize how we can transmit them. But the transmission part is up for an implementation right now. So theoretically, you can extend it with your implementation to say, hey, my implementation transmit the identity in this way, and that's how it is used for authorization. Thank you.